Good morning students. So let us start with the examples from 12th of exercise 5.5. So 12th question starts with find dy by dx of the following functions from given exercises 12 to 15. So 12th, what is given students? It is given as x to the power y plus y to the power x is equals to 1. So in this function we need to find dy by dx. So here again same procedure students. Consider this as u, consider this as v, and you can observe here we have constant 1, right? So if you consider that as u, if you consider x to the power y as u and y to the power x as v, then what you will get? You will get it as u plus v is equals to 1. Now differentiate with respect to x. So if you differentiate with respect to x, what you will get? Du by dx plus dv by dx is equals to, what is differentiation of a constant students? Differentiation of a constant is 0, right? So we got this equation. Call this equation to be equation 1. Now what we have to do? We have to find what is du by dx, we have to find what is dv by dx, and then we have to substitute in equation 1. So let us do that. Now what is u? U is nothing but x to the power y, right? So what we have to do here? We have to find what is du by dx. What is du by dx? So again what we have to do? Take log on both sides. Take log on both sides. So if you take log on both sides, what you will get? Log u is equals to y log x. This exponent will come to the left hand side. Right? So what you will get? Log u is equals to y log x. Now let us differentiate with respect to x. Let us differentiate with respect to x. Observe here students. It is in terms of u, you are differentiating with respect to x. Right? So what is the differentiation of log u? It is 1 by u into du by dx is equals to 1 by u into du by dx is equals to y into log x. So again it is product of two functions. So here we are going to use product rule, or else you can call it as Leibniz rule. So how we shall use the product rule students? First function will differentiate keeping the second function as it is, plus then we will keep the first function as it is and differentiate the second function. So let us differentiate the first function. What is that? dy by dx into log x. See, first function we have differentiated with respect to x, and second function you have kept it as it is, right? Next, keeping the first function as it is, differentiate the second function. What is second function? It is log x. So differentiation of log x is 1 by x. So if you simplify this, what you will get? Du by dx will be equal to, this u will go on the other side. U is nothing but x to the power y into, what all things you will get? X by y plus log x into dy by dx plus log x into dy by dx. So this is, call this as second equation. Call this to be second equation. Now let us find what is dv by dx also, right? So since this y is equal to y to the power x, with a similar procedure we need to find what is dv by dx. So what you will do here students? Again take log on both sides. If you take log on both sides, what you get? Log v is equals to x log y. X log y. This exponent x it will come on the left hand side. Now let us differentiate it with respect to x. Differentiating with respect to x. How we shall differentiate students? Here you can observe it is in terms of v, and we are going to differentiate it with respect to x. So differentiating with respect to x, what you will get? 1 by v into dv by dx is equals to, observe here. Again it is product of two functions. X is one function, log y is one function. So here we are going to use product rule, or else you can call it as Leibniz rule, right? So now first differentiate the first function, that is 1. Keep the second function as it is. Differentiation of x is 1 and keeping the second function as it is, plus next keep the first function as it is and differentiate the second function. Log y is my second function and we are going to differentiate it with respect to x. So what is the differentiation? It is 1 by y into dy by dx. It is 1 by y into dy by dx. So if you simplify these, what you will get? dv by dx would be equal to, this v will go on the other side. This v will go on the other side. What is v? It is nothing but y to the power x into log y plus x by y into dy by dx. Call this as equation 3. So you got both the values du by dx as well as dv by dx. So substitute these both equations, equation 1 as well as equation 2 as well as equation 3 in equation 1, and thus solve for dy by dx. You will get the answer. I hope you can do that, students. Okay. Similar example we have 13th. 13th also is similar. 14th is very easy. That also I want you all to do it. Next comes 15th question. 13th is similar to this one, students. You can do it. 14th is easy. It involves few number of steps. Next comes 15th, right? Yes, 15th. xy is equals to e to the power x minus y. xy is equals to e to the power x minus y. Now how to solve this? See, students, here also what we will do is, we will take log on both sides. We will take log on both sides. So if you take log on both sides, what will you get? Log xy is equals to log e to the power x minus y. Right? I hope you all remember what are the properties of logarithmic functions. Log mn is equals to log m plus log n. Right? So here we have product of two functions. So log xy will be log x plus log y. Here again you are going to use one more property of logarithmic function. What is that? Log m to the power n will be equal to n log m. Means exponent will come to the left hand side. So what you will get? X minus y log e. As I have told you, students, if they have not given you any base, please understand that base is e. If no base is given, then it is understood that base is e. Right? So what is log e to the base e? I hope you all know the value, right? Value is equal to 1. So what equation you will get? Log x plus log y is equals to, since log e to the base e is equal to 1, you will get it as x minus y. Right? Now we are going to differentiate it with respect to x. We are going to differentiate this whole thing with respect to x. So observe here. Here it is in terms of x. So differentiating with respect to x, what you get? Simply it will be 1 by x. But here it is log y. If you are going to differentiate this log y with respect to x, first of all you will differentiate it 1 by y into dy by dx. Into dy by dx. Now here, what is differentiation of this term on the right hand side, students? Differentiation of x is 1. Differentiation of y will be dy by dx. Differentiation of y will be dy by dx. So if you solve and simplify, dy by dx would be equal to y into x minus 1 divided by x into y plus 1. If you simplify this whole thing, that answer you will get for dy by dx. So dy by dx will be equal to y into x minus 1 divided by x into y plus 1. Right, students? Let us go for the next example. they have given us the function f of x and they have asked us to find derivative of the function at point x is equals to 1. This means f dash of 1 means, of course we know, right, what is dy by dx? This is derivative of the function y, and we can also represent it by f dash of y. I have already told you, we have two representations for derivative of a function. Either we can represent it like this or we can represent it like this, right? So f dash of 1 means, f dash of x means what? It is derivative of the function. Now here a function is f of x. So derivative of the function f of x is f dash of x. They have asked us to find what is f dash of 1. Means, to find that, first of all we need to find this, right? We have to first find the derivative of the function at point x. Then we can substitute 1 in place of x to find the derivative of the function at point x is equals to 1. Right, students? So let us first find what is f dash of x. Means, let us first of all find what is, suppose if I consider, for time being, let me consider it as y. Let me consider it as y. So dy by dx, we have to find dy by dx, right? Before that, what we are going to do? We are going to take log on both sides. Just I have considered it to be y, so that solution could be easy. Okay, so if you take log on both sides, what you will get? Log y is equals to log of this whole thing. And you can observe here, this whole thing, this is a product of 4 terms, right? So product log, since log m n, if it is product, then what you will do? You will add log m plus log n, right? So what you are going to do here now? It will be log 1 plus x plus log 1 plus x square plus log 1 plus x to the power 4 plus log 1 plus x to the power 8. So by using the property of logarithmic function, we will get this. Now we can differentiate it with respect to x. Differentiating with respect to x, what do you get? 1 by y into dy by dx. Right? Next, first term if you consider, as we have already done such type of examples, log 1 plus x differentiation would be, first of all you will differentiate it 1 upon 1 plus x into differentiation of this bracket term. What is differentiation of 1 plus x? It is 0 plus 1, that is 1. Right? It is 0 plus 1, that is 1. Next, log 1 plus x square, that would be 1 upon 1 plus x square. Let me write it in bracket. That would be 1 upon 1 plus x square into differentiation of this bracket term. What is differentiation of bracket term? Again the constant differentiation is 0. 0 plus differentiation of x square is what? It is 2x. So 0 plus 2x is 2x. Right? Next, differentiation of log 1 plus x to the power 4. That would be 1 upon 1 plus x to the power 4 into differentiation of this bracket term. What you will get? 0 plus 4x cubed. I hope you can do this differentiation, students. Polynomial function differentiation, I told you. d by dx of x to the power n is equal to n x to the power n minus 1. So you need to use that formula here. If you find differentiation of x to the power 4, you will get this answer. You can check. Similarly, differentiation of this is 1 upon 1 plus x to the power 8 into 8x to the power 7. Into 8x to the power 7. So like this, we will carry the differentiation. Now if you simplify this, what you get? dy by dx will be equal to, you will take this by the other side. Now here you are going to write this whole thing y. Right? What is that y? 1 plus x, 1 plus x square, 1 plus x to the power 4, 1 plus x to the power 8. So this is my y. Okay? And what are these things? Here 1 by 1 plus x into 1. It is 1 upon 1 plus x plus 1 by 1 plus x square into 2x. That is 2x upon 1 plus x square plus 4x So we have found what is f dash of x. Now we can easily find what will be f dash of 1. See students, we have found what is f dash of x. So now we can find what is f dash of 1. In place of x, we need to substitute 1. So if you substitute 1 and simplify, you must get answer as 120. You will get this answer. Please check it students. Here in f dash of x, you need to substitute in place of x as 1. Then you will get this answer. So like this, we have to find the derivative of the function at some particular points. Right? Let us go for the next question. 17.1. So 17th question, differentiate in 3 ways mentioned below. The given function is x square minus 5x plus 8, x cube plus 7x plus 9. So this is given. They have asked us to differentiate in 3 mentioned ways. First of all, you assume this to be y. Okay, assume this to be y. Now we have to find the differentiation of this y. First, by using product rule. Second, by expanding the product to obtain a single polynomial. And third, by logarithmic differentiation. And lastly, they have asked, do they all give the same answer? Of course, they will give the same answer, students. Use any possible way you want. Answer would be always same. See, now if I apply the product rule here, what will be my dy by dx? Dy by dx will be, you will differentiate the first function. What is differentiation first function? 2x minus 5. Keeping the second function as it is. Keeping the second function as it is. Second, we will keep the first function as it is. It is x square minus 5x plus 8. And then we will differentiate the second function. 3x square plus 7. I hope you are understanding how I am differentiating, students. Differentiating first function x square minus 5x. Differentiation of x square is 2x. Differentiation of minus 5x is minus 5. And differentiation of 8 is 0. Keeping the second function as it is. Next, keep the first function as it is and differentiate the second function. So if you simplify that, you will get one big polynomial. Okay. This is finding dy by dx by product rule. Next, we can also find dy by dx by expanding the product. Now second, this is first method by using product rule. By using second method. What is second method? That is easy. You have to expand this product. Like x square into x cube is x to the power 5. X square into 7x, that is 7x to the power 3 plus x square into 9, that is 9x square. Similarly, you need to find all the other terms. And then you find dy by dx. That is finding dy by dx by expanding the two products. Okay, you can find that and again simplify. Lastly, you have to find dy by dx by using logarithmic differentiation. Means what? Take log on both sides and then find the dy by dx and simplify it. And please, this is for your homework, students. Please check. You can verify that answers from all these 3 methods will be same. They will be same. So you use any of the method, whichever you want. Dy by dx means differentiation will not vary. It will be same. Okay. Now last question, 18th. Question. If u, v and w are functions of x, then show that. See students, they have asked us to show that in 2 ways. First, by repeated application of product rule, and second by logarithmic differentiation. d by dx of u, v, w. See, already we have done such example. We know how to find the product of 2 functions, u dash v plus v dash u, right? Here they are asking us to find the product of 3 functions, right? So what we will do here? To find u, v, w, the whole dash, we have considered the LHS. These are LHS, right? I hope you can see. repeated application of product rule. Because again we are using product rule, hence it is called as repeated application of product rule. So if you again use product rule here, it would be u dash v plus v dash u into w plus u v w dash. This is written as it is. So if you simplify that, what you get? U dash v into w plus v dash u into w plus u v w dash. If I write it in terms of du, see u dash is what? Du by dx. U w is written as it is. V dash is written by dv by dx. U w is written as it is. U v is written as it is. What is w dash? It is dw by dx. So you can observe this is nothing but my RHS. We have considered the LHS and hence we proved the RHS. This I have used repeated application of product rule to show LHS is equal to RHS. They have asked us to show LHS is equal to RHS by one more method, that is logarithmic differentiation. I want you all to do it. Okay? So use logarithmic differentiation to show that LHS is equal to RHS. So this ends with exercise 5.5. In my next class we will start with derivatives of functions in parametric form. That is also very interesting. But please you have to complete these all examples which we have left in middle of this exercise 5.5. If you have any doubts, please let me know in my next class. Thank you all. Have a great day.